Okay, so then moving on to percentiles, which is a little weird, right? And I'm glad we actually have a day separated for that for you. Okay, so percentiles are strange, and it's actually going to get stranger even beyond this data because I think this one would make sense. But what I was saying to finish my thought, Stats Guru, I always call it's Mr. Lorkowitz. You may have him. I think his last year is 2 years from now. If you take statistics, hopefully he's still teaching it. Done it for like 30 some years. I always go to him for stat questions because above and beyond like knowing what's going on with that stuff. Um, we're dealing with small data sets. When you deal with big data sets, what's going to happen here today doesn't really occur. But I'm still going to go through it so you understand a thing about this and what's going on here. So, as always, this is the same data set that we had from the very beginning. I got to get my thing working here where we had this smattering of data and then we had to put it in order and then make a box and whisker plot. And now we're taking that same data and finding percentiles, which actually is good to go over. You're a sophomore. I wish you were taking a practice SAT. It's always happened in the past, except for last year. The SAT was canceled completely because of COVID. And this year, we're only taking the juniors, I guess, just to make sure our building is less populated with a bunch of people. So, but usually at this point, you would take a practice SAT. Anyway, you're not, but the juniors are. And percentiles are a big deal. Actually, colleges look at them. What percentile are you on the SAT score? And then if you take the ACT on your own, it's the same. What percentile are you? And then they use that for, are you, good for our college? Will it work or not? Kind of thing. So those are kind of big deals. So let's read together. By read together, I'm going to read and you listen. Like this is story time with Mr. Samuelus with fun math words. But for instance, 64th percentile. This is what's important. You are finding, I thought I hit my pen. Yay, good start. You are finding the number in the data that has greater than 64% of the data below it, at least. So if you're the 64th percentile on the SAT, you are above 64% of the people. That's what 64th percentile means. So let's get that figured out first. Okay. Now, we have a list of 24 grades here. The SAT, I couldn't even guess. We could probably look this number up. How many on average take the SAT yearly on the date, April 13th? And it's going to be in the millions. So that's what I'm talking about. The stat guru, Mr. Lorkowitz. Usually, when you're dealing with data, it's a bunch of it, like millions and millions and millions of numbers. So this is kind of like a Mickey Mouse example to just explain what happens here. So this is what we do. Well, first of all, how many numbers do you have in the list? True SAT, millions. This one, we only have 24 numbers. So something weird is going to happen with this. So to find the 64th percentile, it's actually very easy. You take 0.64 and multiply it by the amount of numbers in your list because you want to find out which number sits in the position in our list where 64% of the numbers are below that. Okay, which with a small list, there's kind of a gray area here. Okay, so this is what's weird. Number one, 0.64 times 24 equals 15.36. Is there such thing as the 15.36th number in the list? First of all, yes or no? The answer to that, of course, is no. So now we have a choice. Is it the 15th number or is it the 16th number that I want in the list? That has 64% at least of the data below it. All right. So what do you think it is? Let's put this in the chat right now. Should I go to the 15th number or should I go to the 16th number in the list to ensure that I have at least 64% of the data below me? Look at what's going on in the chat, and I love it because some people are putting 16, some are putting 15, and now it looks like 16 is starting to take control, but then I got a couple other 15s. And now I'll answer the question. Let's find first of all the 15th number in the list. And you're mathematically rounding down in your head. I think it was here that we had the split in the list. That's where the median was. So this is the 12th number. This is the 13th, 14th. This is the, okay, we got lucky. But which 85 is it? Is it the first or the second? So here's what you got to understand. If I pick the 15th number, if I round down, then this is going to be less than 64% of the data below that number. So it is not and should not be that 85. We got lucky though. Both of these are 85, so we would have been right accidentally. So it is not the 15th number. You have to go up to the 16th to ensure that you have at least 64% of the data below that number. Rounding down, you reduce that percentage. So you definitely always round up to the next number to ensure this percentile is covered. So everyone that put 16th number in the list, you were correct. Don't worry about it if you didn't. I want, you go through that and say, "Oh, I got that wrong." That's like a brain wrinkle. Okay, I won't do that again. That's why it's not a big deal to do that. 16th number in the list, which is still 85. We got lucky that that 85 was that repeated number over and over again. So 85 represents in this small data set at least the 64th percentile. And again, in big numbers, something similar to this happens, big amounts of numbers, but yeah, it's a little strange. Okay, and then 20th percentile. Okay, fine. 20% of 24 equals, I think I got 4.8 from before. Yeah, 4.8 number. Eh? There is no such thing as the 4.8 number. Then if I were to ask this one, everyone probably would have said the fifth number. And you would have been correct. So we have to go always round up and then find what the fifth number in the list is. One, two, three, four, five. So 66 at least is the 20th percentile. At least 20 percent of the data is below that. All right. And that's kind of how you calculate with a small list of numbers. And now I'm going to get even stranger, but I really want you to understand this concept. And again, talking with Mr. Lorkowitz, this kind of thing is when you're dealing with small data lists, it's kind of, arbitrary, but it's all right. Hey, let's say we take a quiz, and I'm doing this on purpose. Let's say we take a quiz and someone scored a one, someone scored a two, someone scored a three, someone scored a four, five, and then another person scored a six, seven, eight, and then someone scored a nine, and then guess what the next one? A 10. So I'm doing this on purpose because I wanna have a little thought bubble with you here. Okay. So here's my data list. It is a very strange one. Wow. Okay. And then I want to find the 20th percentile. In the chat, after what I've just covered, in 5 seconds, tell me what number in the list probably represents the 20th percentile. Hold on. Five, four, three, two, one, go. Okay, good. Ooh, weird. Too good. Interesting. See how the thing goes. Everyone should answer. So if you haven't typed, trying to get in my head. Alessandra, you answered twice. Then Lauren came in. Ooh, Lauren came in with Patrick. So Alessandra, Lauren, and Patrick are correct. Isn't that wild? Because sure, the 20th percentile, we have first of all 10 numbers. And then this is what's going to blow your mind. There's 10 numbers here. So the 20th percentile of 10 numbers equals the second number. But remember the definition of percentile. The second number is 2. What percent of the data is below 2, everybody? Don't put it in the chat. You should answer that to yourself. 10%. So, yes, even in a case where you land right on what the number is, like what it's right on the second number, you still have to go to the third number in order to do this. And this is why you will see that in the chat. The true answer for this is 3, Or I'll tell you what our stats guru said. Because now look at this. If I pick 3 as the 20th percentile, isn't 20% of the data below it? And the answer to that is yes. Okay, here's another thing that the stat guru said. And actually, I read this online and this kind of blew my mind, but now I get it. Or what you could do is take the average of these two and answer that, because 2.5 is a number that doesn't exist in the list, but you understand that those numbers are below 2.5 and they are 20% of the data. So they do one or two things in statistics. On my key for the homework assignment, when this happens, I go up to the next number on the list. And from the stats guru, we found out that that was an either or situation. So good job. It was Alessandra, Patrick, no, and then Lauren. Lauren came in at the end there and agreed with Alessandra and Patrick. You guys were correct. Now let's make up a new list. Let's have a real test here. And I'm going to keep the numbers at 10 numbers again, just to piggyback off what we said here. 25. Let's make it out of 25 points. I get a 25, a 24, I got a 19, got a 17, got a 22, 21, 22. I don't think I have to read the numbers. 1, 2, 3, 4, 5, 6, 7. Here we go. We got that 4. These kids. 1, 2, 3, 4. Do your homework. 5, 6, 7, 8. All right. 16. That's not so great either. And then a 20, Michael Jordan. Let's get Michael Jordan in there. Nice. Okay, so as always, when you have anything, if you're doing whatever, you put this in order. You don't need your calculator, the list feature, and then put these in order using that. It takes too long. So I just wanted to show you that that's a feature that we use in high level stats, because then you do some high level stuff and then you want that in the list. We're just doing kind of little representations of stats, just some little ideas, and then little introduction, let's call it that. Okay, and then this is why you do this, because you may make a mistake. As you cross these off, what if you look back up in your list and you see 18? Oh no, I forgot 18. I got to shove these over. Again, 23, 24, and 25. And I did 10 numbers again to really hammer down. It's easy to compare 10 numbers to 100% and understanding percentiles. So one more time, we're going to find something different, the 30th percentile. Well, when you look at the list, you probably already know the answer. Okay, but I'm just giving you an idea of how you do this when lists are bigger and they're not nice even numbers like 10 numbers or like 50 numbers or 51 or 52 numbers or a million. All right. So you probably already know the answer, but there's 10 numbers again. So 0.3 times 10 numbers means we need the third number, but we don't. Just hammering down one more time. If we write down the third number as the 30th percentile, that only has 20% of the data below it. So I must go to the next number to make sure I have 30% of the data below it. Very strange with percentiles. So 19 or the average of those two. I would accept that number and I'll be ready for that, because 18 doesn't exist on the list. But if I graph it here and put 18 right there, then 30% of the data is below 18. So it's one or the other, directly from our stat guru. Okay. So I think that's good enough. It is a little conundrum with percentiles. And like I said, you will see the answer key on those particular questions, what I do on that. 100%. Okay, think we're good. Don't have anything else to really drag on out and keep you here any longer. So have a good day. See you on Thursday/Friday.